In this video, we're going to cover the properties of logs and also some examples that use properties of logs. The first property is base a log of 1 equals 0. So the log of 1 is 0 no matter what the base is. So for example, natural log of 1 equals 0 since natural log is log base e, and we get log base e of 1 equals 0. And this applies to any base, so we could have log base 7 of 1, we get 0. Also base 10 log of 1 is 0. Log using any legitimate base of 1 will equal 0. The next property is base a log of a will equal 1. Here's an example. Log of 10 equals 1 because log of 10 is the base 10 log of 10, and that equals 1. Another example, ln of e, which is log base e of e, will equal 1. Or we could have log base 3 of 3, that will equal 1. Or log base 7 of 7, that will equal 1. It applies to any base. The next property is what I call the product rule for logs. Log base a of u times v equals log base a of u plus log base a of v. So when we're taking the log of a product, we add logs. Here's an example. ln of 2 plus ln of x. By this property, we can rewrite that as ln of 2 times x. Along with the product rule is something I call the quotient rule. Log base a of u over v is log base a of u minus log base a of v. If you're taking the log of a quotient, you subtract logs. Here's an example. When we have log base 3 of x minus log base 3 of y, by this rule, we can write this as log base 3 of x over y. This next rule is something I call the exponent rule. Log base a of u to the n power equals n times the log base a of u. You can take that exponent and move it out front. Here's an example. We have ln of e squared. That's going to equal 2 times the natural log of e. And then we can take that natural log of e out and replace it with 1, so we end up getting 2 times 1 equals 2. So in this example, we actually use two properties. And the last property is called the change of base rule. If you have log base a of x, you can rewrite that as a quotient of two logs with whatever base you want and write it as log base b of x over log base b of a. Here's an example. Base 7 log of 49. By this property, we can write this as base 10 log of 49 over base 10 log of 7. Now, if we put those numbers in our calculator and divide out, we get 2. Well, we could have figured this out without this rule because we know that 7 squared is 49. So I'll show you another example where we can't figure it out that way. Log base 9 of 12. We don't have a base 9 log key, on most calculators that is. But by this rule, we can write this as ln of 12 over ln of 9. We can choose whatever base we want. Now if we're going to use our calculator, we should choose base 10 or base e. Here I'm choosing base e. When we find ln of 12 and divide by ln of 9, we get an answer of 1.131 when we round to 3 places. Now we'll look at a few more examples. We'll start with the example where we simplify ln of e cubed by applying properties of logs. Well, by the exponent rule, we can take that 3 out and move it out front in front of the log, so we get 3 times natural log of e. And we've already seen that ln of e turns into 1 because ln of e is log base e of e. So we get 3 times 1, and that gives us an answer of 3. In this next example, we're going to write 2 times log base 3 of x plus log base 3 of y as a single log by using these properties. We start here by taking that 2 that's in front of the first log and moving it back as an exponent. This gives us base 3 log of x squared plus base 3 log of y. We can apply the product rule to this quantity by combining the two logs with multiplication, and we get base 3 log of x squared y. And you notice you don't need the parentheses, so I write it both ways here. The parentheses help clarify that you are taking log of the whole quantity, so I tend to include them. In this last example, we're going to rewrite log of x squared over square root of y as a sum or difference of logs or multiples of logs. You notice there's no base here. That means it's a base 10 log. The same properties apply. We start by applying the quotient rule. We take that log of a quotient and write it as a difference of logs, and we write it as log of x squared minus log of square root of y. Now we want to use the exponent rules for both of these. The square root of y is the same as y to the half power, so that gives us an exponent of 1/2. So we take the exponents and move them out front, and we get 2 times log of x minus 1/2 times log of y. And that's our final answer. And I've created another video besides this one with some examples that are a bit more complicated, so I would encourage you to watch that video as well.